Hello, ladies and gentlemen.
Hello.
Hello.
We need to have a little bit more people. They are adding. And I will start right now. Okay. So today is 23rd, and I'm going to check our attendance right now. Unfortunately, they are not all people here as participants, but it's okay. They are maybe will be a little bit late. Okay, so Andrew.
Here.
Tima. I think I saw her. Okay. Lorraine.
Here.
Aline.
Here.
Juanita. Yoran.
Here.
Gabriel. Divina.
Here.
Chantal.
Here.
Guangxi.
Here.
Kyle.
Here.
Matthew. Matthew.
Here. Here.
Julian.
Here.
Nathan.
Here.
And Alejandro.
Here.
Okay. Do we have anyone whose name I did not call? Yes, no? Okay. What I'm planning to do right now, so if you have questions, you can address to me. And I'm planning to continue my work with you, solving problems with inverse trigonometric functions. So feel absolutely free to ask me as many questions as you need. Let me see what we had yesterday at the end of our class. It should be on my scratch papers. Okay. Is it what you had at the end in your notes?
Yes.
Yeah.
Yeah.
Okay. If you checked Wiley Plus, you could see probably that there is another homework with the material from section 7.8, and this is about inverse trigonometric functions. Unfortunately, that section is so tiny and it does not show really nice problems, which I like to see in the section about inverse trigonometric functions. This is why I'm planning to show you other problems as examples, which are not from your textbook, but you can find quite many similar problems or applications of that problems or methods at many math textbooks, and for trigonometry, and for pre-calculus, and for calculus, etc. So I started talking about some properties like domain, range, or some important formulas for basic arc functions. And I already talked about y equal to arc sine x. Right now, I will talk about the next function, which is arc cosine x. So y equals to arc cosine x is another arc function. So if you have this formula like y equal to arc cosine x, or you can say inverse cosine x, here x, which is the independent variable, represents numbers, and these numbers should be between -1 and +1, including a -1 and +1. Y here represents a main angle, which we use like a reference angle for many occasions. So I would like to talk here again about domain, about the range. I will show you another half of the circle, which will represent a range of that function. And I will try to solve some problems again for arc cosine. And I am planning to show you the formula as I showed for arc sine of minus x. This is my plan at the beginning. I'm starting. Domain for that function is absolutely the same as for arc sine x. It is a excuse me, I said semi. It is a closed interval from -1 to +1, or you can just say it is the segment -1, +1. The range here will be not the same as we had for arc sine. This time it will be the top half of the circle, including endpoints. So which means the range here is from 0 to pi. It is a first quadrant and the second quadrant. Now, if you look at the shaded half of the circle for arc sine, so it was the right half of the circle. For this function, arc cosine, we have a top half of the circle. Top half of the circle. Again, top half of the circle. So basically, I can write that range is from 0 to 2 pi. Both ends are closed, means included. If x in this function is a positive number, then this angle will be from the first quadrant. If x is a negative number, then your angle y will be from the second quadrant. I'm going to write right now the formula for arc cosine of -x. Again, unfortunately, this is not in your textbook, but it can easify your process working with these functions. It will be pi minus arc cosine of +x. I'm going to box that formula. Arc cosine of -x equals pi minus arc cosine x. I'm not planning to talk a lot like domain, ranges, other properties for arc cotangent, but because formula is quite close to that, I'm going to write right here the formula for arc cotangent of -x. It also will be equal to pi minus arc cotangent of +x. This is why the formulas are matching. I decided to actually provide that formula as well. Let's solve some examples here. Are you okay? Can I continue?
Yes.
Yes. Yes.
An example, let's say I have arc cosine of 1/2, positive 1/2. It means I'm looking for the main angle in that half of the circle for which cosine will be equal to positive 1/2. Knowing that in the first quadrant, all cosine's values are positive, I need to choose an angle from the first quadrant. So I'm going to refer this question to all of you. In first quadrant, which angle has cosine equal to positive 1/2? Give it in radians, please.
Pi over 3.
So the answer here is pi over 3. Thank you very much for your help. So the answer is pi over 3. Let's say that now we need to find arc cosine of negative 1/2. It means that this is the main angle for which cosine should be equal to negative 1/2. Definitely, this should be an angle from the second quadrant. So I'm going to apply that formula which I have in this box. So it will be pi minus arc cosine of positive 1/2, which will be pi minus pi over 3. The angle is 2 pi over 3. And 2 pi over 3 is definitely from the second quadrant because it is equivalent of 120 degrees. I wrote this on the bottom of the page. So arc cosine of negative 1/2 equals pi minus arc cosine of positive 1/2, which is pi minus pi over 3, and the answer is 2 pi over 3. Can I move to the next example?
Yes. Yes.
Yes.
Let's say I need to find a value of arc secants. And this is arc secants of 2. Yeah, this makes sense because we have definitely angles for which secants will be equal to 2. It is a reciprocal of, I'm talking about direct secants. It is a reciprocal of cosine. And I feel, let's say, much more comfortable dealing with arc cosines than arc sequences. And even though I'm a professional mathematician, but me also, I have same feelings toward certain functions. Definitely, I can do that much easier than many students, but I would right now show this from the point of the view of that normal student. So it will be now changed to arc cosine, but I cannot write anymore that it is arc cosine of 2, because if for certain angle secants is equal to 2, for the same absolutely angle, cosine will be equal to the reciprocal of 2, which will be 1/2. And excuse me, and this y. Now, the answer here will be pi over 3. You can see for all these examples, I use the reference angle, pi over 3. And same approach, let's say, we already talked reviewing arc sine and arc cosine. Let's say this time I need to find the value of arc secants of square root of 2. Arc secants of square root of 2. I would use here absolutely the same strategy. So look what I'm going to write down, that it will be arc sine of the reciprocal of that square root of 2, which is arc sine of square root of 2 over 2, if I need to get rid of the rationality. And dear ladies and gentlemen, what would you have here as an answer for arc sine of square root of 2 over 2? Can you please repeat one more time?
Pi over 4.
Yes, definitely. If I need, let's say, to find arc cosecants of negative 1, I would convert this into arc sine. What is the reciprocal for negative 1?
It's just -1.
How can you answer that question? Just simply divide 1 by what you had, -1, and what would be the answer?
-1.
Definitely. What is the reciprocal for 1?
1.
1. What is the reciprocal for -1? -1. So, and now I'm going to think about how to apply, let's say, well, you can answer this right away, but I just like to show that application of formula which I boxed, because I can write answer right away, not using any other formula. But if we are applying that formula in the box, it will be minus arc sine of +1, and definitely the answer here will be negative pi over 2. With your permission, can I move to arctangent?
Yeah.
Yes.
Thank you. So the other one, arctangent. What do we have here? Again, here, x is a number which represents the value of tangents of angles. And if we compare this function with its direct function, because it will be y equal to tangent x, the range for tangent x is a domain for this function. And if you remember, the range for regular tangent was set R. This y domain for this function is set R. So x can be any real number, positive, negative, 0, greater than 1, less than 1, doesn't matter. It is set R, but not y. And here again, we're talking about the main angle for which tangent will be equal to that x. So because y equal to arctangent x means it is a main angle y for which tangent is equal to x. Basically, I can rewrite, if I like, I can rewrite that like x equals tangent y. Solving this for x. from that equation. This means that range will be now also consisting of the angles from the fourth quadrant and first quadrant, but this time we will not include the endpoint. So it will be we will not have brackets anymore. We will have parentheses from negative pi over 2 up to positive pi over 2, again with round parentheses. So you can see it reminds us the range for arc sine x, but the difference is that for arc sine x, the range included endpoints, pi over 2 and negative pi over 2, not here, not anymore. In this case, if we like to show half of the circle, it will be again the right half of the circle, but only at endpoints. Please place open circles. So it will be open at pi over 2, it will be open at negative pi over 2, and all other parts can be shaded. This is what we have. Let me actually write here 0. So this is the range for arc tangent. And let me write another formula for arctangent of negative x. And I boxed that formula, and you can see it is absolutely same type of formula like we had for arc sine of minus x. Okay. Questions about what we just covered?
No.
No.
Thank you. Let's continue. So let's solve some problems. And you know what, again, unfortunately, your book does not have quite nice problems for that particular material. This is why I will be forced to show more examples from not your book. I can solve some problems from the textbook if they catch your attention. So you can look at problems which you have for this section. These problems for that particular section start at page number 313. And can you look at, we have here some problems from 1 through 11. And on the back, we have a continuation on page number 314. Can you tell me if you like to see something right now from that spot? For example, from 1 through 11, does anything catches your attention?
What was the page?
I cannot hear.
What was the page?
313, 313.
Thank you.
Mhm. Would you like to see something from problem number 1?
Yes, it's fine.
Yes, please.
Okay. Number 1, what should we do here? Evaluate each expression. I really recommend you to have calculators because we can approximate. So, okay. Part A. Evaluate sine x if x equals to 1/2. Can you see it has a small degree sign?
Yes.
So which means, what can you write down? You can write sine, and instead of x, please write in parentheses 1/2 of degree. So this is not the problem related to inverse trigonometric functions. This is the value of direct sine for angle, which is equal to 1/2 of degree. Please grab your calculators, turn them on, push button which says mode, and now look at the third line. If your radians are highlighted, and I have radians highlighted, I need to switch to degree. So I am using that arrows to move to the third line, moving to the right, highlighting degree, and push enter. Right now, your calculator is in the degree mode. And go back to the home screen. So, and now I am pushing button which says sine. It comes with parentheses. 1 divided by 2, and I know that it is in degree mode, and push enter. This is approximately 0.0087. Let's say I am going to have many digits, 0087, and I'm stopping here because after 7 I have 2. So this is the answer. Approximately 0.0087. I evaluated. If you talk about part B, there is a different symbol. There is an arc sine of x if x is 1/2. And this is no degree sign here anymore because under symbol of arc sine, I should have a number. So then it is arc sine of 1/2. You can use parentheses around 1/2, and because it is not negative, you just can write arc sine of 1/2. Is it a positive 1/2?
Yes.
Yeah.
Should I choose the angle from the first quadrant or the fourth quadrant?
First quadrant.
First.
Okay. Which angle in the first quadrant has sine equal to 1/2?
30.
We need to do that in radians. Is it pi over 6?
Yes.
Okay. It is pi over 6. Yeah. In radians, it will be 30 degrees. So you can look at your book. If it gives you the answer in radians, it will be 30 degrees. Okay. And the last one here is part C, which is sine x in parentheses -1. This is not an inverse. Okay, 1 second, please. If, I really apologize, x is equal to 1/2, and again, you can see that symbol of degree. So it is not an inverse function anymore. This is a sine of 1/2 of degree, which we have to raise to the negative first power. So which means it is actually 1 divided by sine of 1/2 in parentheses degrees. So I would not separately evaluate and divide 1 by this number which we had in as an answer in part A. I would just enter this exactly how it looks into our calculator. So it will be 1 divided by sine of 1/2, 1 divided by 2, close parenthesis, and enter. And I'm ready to approximate 114 point, let's say 59, because after 9 I have 3. I do not want to continue. This is the value. You can see we have all 3 different values here as answers. Okay. Is it okay with you if I now offer you problem number 6 on the same page?
Yes, please.
Did you say yes?
Yes.
Yes.
Okay. Number 6. Solve the equation for the value of theta in the first quadrant. Give your answer in radians and degrees. Okay. 10 tangent theta minus 5 equals 15. Theta belongs to the first quadrant. 10 tangent theta minus 5 equals to 15. Theta from the first quadrant. Let's use algebra. In that equation, can I move -5 from left to right?
Yes.
Is it going to be plus +5?
Yes.
If you add 5 and 15, do you get 20?
Yes.
Can we divide both sides by 10?
Mm-hmm.
Divide by 10. Do you get tangent theta equal to 2?
Yes.
Yes.
Is it positive 2?
Yes.
Yes.
We know that tangent is positive in the first quadrant and the third quadrant.
Yes.
But here we are asked only to find one angle, which is from the first quadrant. So I'm going to look just for this one. How can I find that theta? Tangent equal to 2 is not listed in any table for mandatory angles, for which we definitely need to memorize all values of trigonometric functions. This is why I'm using another approach. How can I neutralize that tangent? I need to apply its inverse function to both sides as a composition. So it will be arctangent composed with tangent theta, and it will be equal to arctangent of 2. Here, in this composition, we have 2 inverse to each other functions. And besides that, theta belongs to the first quadrant. First quadrant is in the range of the outside function. This is why the left side is theta now. So theta is equal to arctangent of 2. This is exact answer, but now actually I will find, according to the request, I will find this in radians using my calculator and degrees. First, they were talking about radians. This why, please press button which says mod, go back to the line number 3 and switch to radians and push enter. Your mod should be in radians. I don't know if you can see or not. Can you?
Yeah.
Yes.
Go back to the home screen and you have a button which says tangent. On the top you have arctangent. So second button, tangent button, enter 2, close parenthesis, and push enter. So in radians, theta approximately equals to 1.107. Do the same thing, but this time in degrees. Go back to mod. Go back to the third line. Now switch from radians to degrees. Push enter. Now it is in degree mode. Go back to the home screen and repeat the same thing again. Second button, tangent button, and you are entering 2, closing parenthesis, push enter, and you have different answer. So it will be in degrees, theta approximately 63.4349. So let's say here I will also approximate having 3 digits. So it will be 435. Don't forget to write the degree sign, because if you don't do that, it is in radians. I'm done. Can I offer you my own examples?
Yes, please.
Yes.
Okay. Let's do that. They're a little bit more challenging, but they are more interesting. Let's say we are looking for arc cotangent of negative square root of 3 over 3. What would I do here? Do you remember I gave you the formula in the box for arc cotangent of negative number? Guys, can you look at your notes? Please. What can I write for that? Can you help me? Please. Where is? Can you see here on the bottom formula for arc cotangent for negative number?
Yes.
Can we apply it? If we have a formula, can we apply it?
Yeah.
Yes.
This is what I'm asking. Can I write this?
Yeah.
English has 2 beautiful words, yes and no.
Yep.
Okay. Would you like to get rid of arc cotangent now? I would. I'm replacing this by arctangent, but this time it will be 3 over square root of 3 reciprocal of that. If you divide 3 by square root of 3, it is actually square root of 3. So it will be arctangent of square root of 3. So which angle in the first quadrant has tangent equal to square root of 3? It is pi over 3. So it will be pi minus pi over 3, which is 2 pi over 3, which is the answer. Okay, so now I would like to talk about some problems which have composition of inverse to each other trigonometric functions. You need to be extra careful because we need to first ask yourselves certain questions solving these type of problems. And I'm going to offer right now you that type of problems. I am having here a textbook for trigonometry course, and this is why it will be much easier to choose these problems from that section. Just 1 second, please. I will be grabbing that section. It is actually 3.1 section. And yeah, I have here quite many nice problems. An example, let's say I'm solving the problem in which I am going to deal with inverse to each other functions. So this is like example number 1, let's say. It has arc cosine composed with cosine of 4 pi over 5. For pi over 5. Arc cosine composed with cosine for pi over 5. Solving this, I accidentally dropped something. Okay, so solving these problems, you need to ask you some questions. Question number 1. Is it a composition of two inverse to each other functions?
Yes.
Yes. After you said yes, you are asking yourself the second question. If that 4 pi over 5 is in the range of arc cosine or not? 4 pi over 5. Pi over 5, it is 180 over 5. It is 36 degrees. 36 degrees times 4. It will be 144 degrees. Is it in the range of arc cosine?
Yes.
Did you say yes for both questions? That's it? You don't need to do anything anymore. You can write immediately your answer. Your answer is 4 pi over 5 because these two functions, they neutralize each other in this composition and they release that value 4 pi over 5. You can do that only if you answered yes for both questions. Question number 1, is it a composition of two inverse to each other functions? Yes. Is 4 pi over 5 in the range of the outside function? Yes, this is the answer. What happens if you answered no, let's say, to one of these questions? Example number, let's say, 2. You have arctangent composed with tangent of same angle for pi over 5. I purposely used same for pi over 5. Question number 1. Are they inverse to each other functions?
Yes.
Yes.
4 pi over 5, which is equivalent of 144 degrees, is it in the range of arctangent? Don't forget, it is the second quadrant. And arctangent's range has fourth quadrant and the first quadrant. So what would be the answer?
No.
No. So which means this time the answer is not 4 pi over 5. What can I do? I will work with that 4 pi over 5. 4 pi over 5, can I write that actually it will be equal to 5 pi minus 1 pi over 5. We did it so many times. Can I?
Yeah.
And I'm going to simplify that fraction. So it will be arctangent composed with tangent. 5 pi over 5 is pi, and minus pi over 5. Is it correct?
Yes.
And now I'm going to simplify again the inside piece. Pi minus pi over 5. It is 180 minus 36 degrees. Is it the second quadrant?
It is.
In the second quadrant, tangent is positive or negative?
Negative.
Negative. I am applying that European rule right now to simplify. So it will be minus. In parentheses, do you have a vertical quadrantal angle or horizontal?
Hor-
Pi is a quadrantal angle. Is it a
Horizontal.
vertical or horizontal?
Horizontal.
Horizontal. With horizontals, do we keep the same function's name or change it?
The same.
Same. So which means I can write down that it will be arctangent of minus tangent of pi over 5. According to the formula, which you have right here in parentheses about arctangent of negative numbers, I can write that it will be minus arctangent of tangent of pi over 5. And now I can proceed to the last step. First, it will be negative, and now ignore now that negative sign because you already took care of that. Do you have a composition of inverse to each other functions? Yes.
Yes.
Pi over 5, which is equivalent of 36 degrees. Is it in the range of arctangent? 36 degrees. Is it from the first quadrant?
Yeah.
Is it in the range of arctangent? Is a difficult question. What is the location of 36 degrees? Is it quadrant number 1? What do we have for the range for arctangent? First quadrant, fourth. Yes, it is in the range. So the answer is negative pi over 5. And I am done with this problem. You can see in this case, we just answered no for the second question, and it changed the strategy because we had many more steps than we had before when we answered yes for both questions. Not all the time we are dealing with that type of problems. Sometimes you can answer no right at the beginning when you are asking yourself about the composition of inverse to each other functions or not. Because from the beginning, you can say, no, it is not a composition of inverse to each other functions. In this case, we need to use completely different strategy, and which I'm going to talk about tomorrow. And probably it will be the last time when I can talk about inverse trigonometric functions, and I will move to another topic. And after that, actually, we are going to talk about a new material which you did not have in previous classes. So this is so far up to today and tomorrow also. It is actually a review of a material, of the old material which you covered before in your previous classes. Definitely, it was a review on more advanced level, but it was a review of old material, starting with let's say polar coordinates. You will be getting actually a new material for this particular level. This is my plan. Can I ask you if you have some questions? If yes, I will try to answer. If no, I will probably will end today's session.
No questions.
No
I
questions.
think we're good. Yeah.
And again, I will try to record that lecture on Zoom, and after that upload this on YouTube. I'd like to know your opinion, because I watched activity on YouTube with that lecture, and I saw some people actually are coming back to that lectures and watch that videos. What do you think? Is it really helpful for you? Because it takes a lot of time to do that. I'm not saying that I will be not doing that. I'm just curious. I'd like to know your opinion. Is it helping you?
It is.
Yeah.
Yeah.
Okay, so I will do that. Everyone, have a nice, beautiful day. Stay safe, and the best wishes to you and your families. Okay?
Bye.
Bye.